Hi everybody, it's Mrs. London. I'm sorry this has to be the way that things are for the foreseeable future, but hope everybody is staying healthy. I miss seeing you guys every day in class. I do want to say that I know some of these topics that we're going to be looking at over the next 6 weeks are going to be a little bit difficult. However, hopefully these videos that I'm posting are going to make some of the topics a little bit easier. And so just take it step by step, take a deep breath. And if you have any questions, always feel free to email me, or you can use the Teams app to start a dialogue and we'll all figure it out together. All right, so you'll notice the first thing in your packet is going to actually be your review of the gas laws that we had already done in the chapter. So all the way up through ideal gas law. And go ahead and complete those problems first. Hopefully you guys remember what you're doing. And there is a periodic table included with those. But after you get through that review, the next part you're going to find is going to start with molar mass and the density of a gas. For molar mass and the density of a gas, what you are going to see is you are going to have a couple different equations. And so our first equation to find molar mass is going to be that molar mass is equal to density times our R constant times T, which is temperature, over pressure. Okay, remember our units, molar mass, that's grams per mole. Keep in mind, molar mass is easy to calculate. If you're already given the gas, so let's say like carbon dioxide, you can easily find the mass of carbon dioxide by using the periodic table. You find out how many carbon, how many oxygen you have, multiply oxygen by 2, add it all together. For density, density is going to be in the units of grams per liter. R, our gas constant, remember, is 0.08206. And that unit, which you very rarely need to remember, is liter atmosphere per mole Kelvin. And then we have our temperature. Temperature is always going to be in units of Kelvin. And pressure is going to be in the unit of atmospheres. Okay? So a good example of a problem where we have to find molar mass is found on the worksheet that's called Worksheet Gas Density and Molar Mass. It is included in your packet. If you take a look at number 5 asks you to find the molar mass of a gas that has a density that is equal to 2.95 times 10 to the negative third grams per milliliter at standard temperature and pressure. Remember, standard temperature is 273 Kelvin and standard pressure is going to be 1 atmosphere. Okay. So we have everything we need to solve this problem. The only issue is take a look at your units for density. Here they're listed as grams per milliliter. We want to make sure they're in grams per liter. So we first have to do a conversion. And so with this conversion, we're going to see that we will write 2.95 times 10 to the negative third grams. And I like to write the milliliters on the bottom like that. Now converting from milliliters to liters, since milliliters is on the bottom, you want to put it at the top, put liters at the bottom. Conversion here, for every 1 liter, it is equal to 1,000 milliliters. So when you do this math and you multiply across the top, you're going to end up with a number that is 2.95, and now that is grams per liter. That's what you want to have for your density unit. Okay, so we're going to plug that into our equation. So our equation is molar mass is equal to our density, which is going to be 2.95 grams per liter times our R constant, 0.08206, times our standard temperature of 273 Kelvin. And we're going to put all over 1 atmosphere for our pressure. Okay. So after we finish this calculation, our molar mass is going to be 66.08 grams per mole, and that is our mass of the gas at that particular density. The other type of problem that you're going to see with molar mass and density is the calculation of density. And to calculate density, you would use the pressure times the molar mass of the gas over RR and T. Okay. Now keep in mind, there's also a note in your notes that talks about what is going to happen at standard temperature and pressure. If a gas is at standard temperature and pressure, then the density calculation becomes the molar mass over top of 22.4 liters. Okay, so you get to a problem where it says, what is the density of a gas at standard temperature and pressure? And it gives you what the gas is. You can easily calculate it just by doing the molar mass divided by 22.4 liters. Such is the case with that same worksheet we were just talking about, the gas and density and molar mass worksheet. Question number one. Question number one says, what is the density of carbon dioxide at standard temperature and pressure? Okay, so again, for this, to calculate density, we are going to need to know the molar mass of carbon dioxide, and we're going to divide that by our 22.4 liters. And so we find molar mass of carbon dioxide. Of course, carbon, there's one of those, oxygen 2. We multiply it by their masses from the periodic table. And we add those together, and we get a total of 44.01 for our mass. Okay, so we're going to go ahead and plug that in up here, 44.01 grams per mole, and we are going to put that over 22.4 liters. And when we do that math, we are going to end up somewhere around 1.96, and that is going to be in the unit of grams per liter. Okay, and that is our density unit, grams per liter. Okay, I hope this helped. If you have any questions, again, always feel free to email me or send me a message on the Teams app. I'll talk to you soon.